We are going to start this, and good morning, good afternoon, good evening. We are going to start this presentation by presenting what's been happening in the French sites. And this is going to be a multi-voice presentation with different contributors. I'm going to start by presenting our study sites and the project approach in the different sites. And this presentation will be done by myself and by my colleague Cécile Erivo. So first, so one of the two sites in France is both sites are in the south of France. This one is close to Nîmes and is called the Vistrinck Aquifer site. The characteristics of this site is that we have a specific land use dynamics. In the past, there have been a strong increase of intensive irrigated agriculture with the development of vegetables and fruit trees and a long-term domination of wine production. More recently, there has been, due to economic crisis of these different production, there has been a decline of wine and fruits production, leading to abandoned land, and that has been partially replaced by extensive, extensive in the sense of not intensive, livestock farming. At the same time, there has been a development of urbanization in infrastructure development, and also related to this infrastructure, biodiversity offset program to compensate for the destruction of habitats related to those projects. The critical zone characteristic of this area is that it's an alluvial aquifer which is exploited for drinking water for about 180,000 inhabitants. And it's also a rich ecosystem with a mosaic of habitats, which creates some particular issue. In terms of critical zone challenges that we address in this project, we can see that there are rapid surface groundwater transfer that has been related to pollution of aquifers with nitrates, especially due to intensive agriculture, and also some effects of urbanization and development of infrastructure on biodiversity. Next for Cécile.
Hello, everybody. So the second site is corresponds to the impluvium of the karsting spring of the Lez, which is the main resource for the drinking water supply of Montpellier and the surrounding municipalities. There are 45 municipalities that are located on the impluvium, and the study area covers 750 square kilometers, mostly covered by natural areas. We can observe three major landscape entities. First, next, please, the western part that is characterized by scrublands, forests, and cereals, and is sparsely populated. We observe a predominance of natural areas. The eastern part is covered by a mosaic of vineyards, small towns, and forests on the hills and crossed by roads. We observe here a higher proportion of vineyards. And then the southern part is located in the peri-urban area of Montpellier. We can observe a higher proportion of urban areas and a strong fragmentation of natural and agricultural areas. Next, please. The study area has been marked by three major land use and land cover changes from the 70s. First, we can observe an evolution of the type of natural vegetation with a shift from open grasslands to forests. That results from the progressive abandonment of livestock farming and wood charcoal burning practices. This is the biggest observed change, with more than 50% of the study area concerned. Next. The second one is a strong urban sprawl that is associated to the high increase in population influenced by the development of Montpellier. This will, however, be balanced against the relatively low proportion of urban areas. That is only 6% of the study site. The third one is the decrease of vineyard areas, mostly located in the western and the southern parts of the study site. But on the contrary, we can observe also a rebound with the development of vineyards in the eastern parts that benefits from a wine quality level. This represents around 5% of the area. Next. So these land use dynamics have potential effects on the hydrogeochemical cycles that are still poorly known. Understanding the influence of these dynamics on groundwater in terms of quality and quantity is essential for actors in charge of managing the territory and these strategic groundwater resources. To address this, CLS will present their work on land use changes characterization. Then Nicolas and Sandra will present their respective research activities to assess hydrogeological effects of land use and land cover changes. These land use dynamics have also potential effect on biodiversity, recreational and landscape amenities, fire risk, etc. Analysis of the perception of these land use changes by the stakeholders is important to understand potential trade-offs associated with potential future land use scenarios. This is the purpose of the work carried out by Ines, which will be presented to you later. Finally, this work lays the foundation for constructing possible future land use scenarios, assessing their impact on aquifer recharge and analyzing the population's preferences by carrying out hydrogeological modeling activities and a dedicated survey that will be completed in 2023. Thank you. Next, so I think this is
Thank you,
a video.
Thank you, Cécile. We're going to present now a video with the work of CLS. I'm going to launch it right now. I have to close and reopen the sharing.
We have worked on two watersheds located in the south of France, called the Lez and the Vistre. Our main objectives were, first, to detect the abandoned lands in those areas of interest by taking advantage of the exhaustive and free access geodatabases we have in France, and second, to study the historical land cover changes over the last 4 decades, focusing on 6 specific land cover classes with a machine learning algorithm and the Landsat images acquired since 1986. Those works are still in progress. For the agricultural abandoned lands detection, the year under study was 2018. We used a methodology developed by Louis Crétin based on the creation of a global mask. This mask is made of a union of polygons surrounding all the lands which were declared as something else than abandoned lands. Then, by subtracting the land register mask with the mask we just obtained, we finally got a first shapefile composed of potential agricultural abandoned lands. As the mask obtained seemed not perfect, some other steps were added to exclude the non-abandoned lands polygons. The first was based on the NDVI analysis extracted from the Sentinel-2 acquisition over the year 2018. Empirically, Louis Crétin found some specificities in the NDVI evolution concerning the mean and the standard deviation of the abandoned lands during this year. By overlapping the polygons on those NDVI products and filtering with those NDVI conditions, we deleted a lot of forests and crop polygons. The last step consisted in using the OZO, a land cover map produced every year since 2016 by the CESBio, to delete the last polygons which showed a ludicrous majority class once overlapped to these land covers. In this example, the majority class of the red polygon is artificial land during 4 years. It has a high probability of not being an abandoned land. If the polygon was classed as something really close to the abandoned land definition, like a vegetation class, it was kept in the mask. Finally, as this process is time-consuming and really specific to this year and the study, we used those polygons as training samples to train a random forest model. The method is simple. We make it learn the NDVI evolution of the abandoned land extracted from Sentinel-2 acquisitions. Using this model over all the pixels of the Sentinel-2 acquisition finally resulted in a map where all the red pixels, shown on the right image, are detected as abandoned land. As we did not have any validation datasets, we are not able to give you the accuracy of this model. But a manual check has been done. The model seemed to find new abandoned lands, but was a little bit too inclusive. Some other vegetation, like sparse grass, were detected as abandoned land, because of their spectral evolution, which is very similar to the objects under study. For the historical land use changes we wanted to find, we downloaded all the Landsat data available on the Vistre and the Les areas between 1985 and 2020. 6 classes were chosen in order to traduce some specific changes we were looking for. The method is quite similar to what we just saw before. By photo interpretation, we drew some polygons surrounding the classes under study. Then we calculated all the indices that could help us in highlighting the classes under study. For example, we used the BSI to get the bare soils areas, the NDVI for the vegetation areas, or the NDVI for the urban areas. Training the random forest to recognize those classes allowed us to produce 3 land covers, one per decade, as shown in the right part of this slide. Here is an example of an urban area expansion which occurred between 1985 and 2020 in the Vistre area. The 2020 land cover shown here is the ESA world cover. We see the red pixels getting bigger over the decades. And here is another area of interest showing changes from the forest class to the crop class. We wanted to produce some statistics about those results, like calculating the crop areas replaced by the urban areas, but the results are a little bit noisy and should be improved before. For this, some solutions are under study, like improving the model, trying with a more sophisticated model, like a deep learning model, or using the nowadays classifications, which have a better accuracy in order to correct some inconsistencies in our land covers.
Okay, so I'm going to continue our presentation now. Sorry for the manipulation. Is it okay? Do you see my presentation?
Yes.
Okay. So so now I'm going to present on behalf of my colleague Nicolas Surdic the work that has been done in the Vistrac aquifer on the impact of land use change on nitrate pollution. So in order to do that, we are using a LUMPS model that simulates both the hydrologic and nitrate transport in a coupled way. It considers the catchment as a whole entity, and we use lumped values of input variables. For example, we use the total surface of a given crop and not its location in the watershed. Lump parameters cannot be measured, so these parameters are determined by the calibration of the model. The BISH model, which is this lump model we are using, its conceptual structure is basically a cascade of reservoirs that are interacting through mathematical function to describe the different fluxes between the reservoirs. The input data are, we use meteo data at the catchment scale, but also we are using farming data that have been collected in partnership with our partners, the NIM Metropolis, and also the EPTB Vistrac. So we have collected data on agricultural practices, on crop nitrogen needs, natural soil mineralization, residual mineralization after harvest. So we use that in order to, the model is developed in 2 different sub-catchment of the overall study site. The case study 1, which is has specific need, the specific interest is to evaluate the impact of abandoned land, because there has been quite a lot of abandoned land in this area. And the second site is still characterized with with intensive farming and still has a strong nitrate pollution issues. So for example, here, if you look at case study 1, you can see the land use dynamics dynamic that has been recreated with a reduction of wine production and reduction of of cereal production in yellow, and then development of abandoned land in gray, and also of pastures. And so we have used that to compute nitrate absorption curves and to calibrate the model. So here you can see the calibration of both the piezometric level and the nitrate concentration. And you see that we have a quite good long-term, we are able to model the long-term evolution of nitrate, for example, but we have a bit more problems for the short-term variation. So we use that as a first attempt to evaluate scenarios. And so we, for example, made a scenario in which we suppose that the abandoned land is recultivated with wheat. And you can see in the last slide, so if you look in the future, so after 2020, that if you compare on the right, the piezometric levels remain the same on the left, but if you look at nitrate concentration on the right, you see that in the case where wheat is recultivated in the gray curve, you can see an increase of nitrate that still is under the 50 threshold, which is the legal threshold, but may create problem if it continues in the future. So I'm going to give the floor to Sandra Lanini now.
Well, hi. Well, I will now present the work we have done so far regarding the water resources on the second French case study. Next. On the Lez watershed, our research objective is to assess the impact of land use changes on the water resource quantity, not quality. And the first step of our work consisted in an evaluation of the modeling procedure sensitivity. Next slide, please. Well, our global modeling approach is divided into 3 steps. First, we have to elucidate the land use changes on the watershed during the last decades. That's the work that has been presented by Cécile and also CLS. And we have to translate some change indicators, which may be leaf area index or NVDI. And these indicators have to be changed into a function that describes the coefficient variations with time and space. And secondly, we use this coefficient function to evaluate the potential evapotranspiration used by the water budget model to estimate the daily effective precipitation. Just click this, Philippe. Well, thank you. And finally, the effective precipitation time series feed a lumped hydrogeological model that simulates the water level in the main karstic plain and calculates the Lez natural discharge. Well, before operating the modeling chain, we conducted a sensitivity analysis study. The goal was to evaluate whether the variation of evapotranspiration induced by land use changes is significant enough to modify the hydrogeological model response. Well, depending on the part of the Lez watershed, three kinds of changes are observed: either an increase of artificial areas, or an increase of vineyards covers, or an evolution of abandoned land from open grassland to evergreen and mixed forest. Considering the hydrological modeling approach, readers have to compare the impact on evapotranspiration of various land cover, which are forest, grassland, and vine. Next, please. Well, the single crop coefficient approach has been used in this study. It has been extensively described by Alan for the Food and Agriculture Organization. The potential evapotranspiration is calculated by multiplying the reference evapotranspiration, which is derived from meteorological data, and this is multiplying by the crop coefficient. This later varies for each crop and for each vegetation type, and it also varies with the phenological stage during the year. For natural vegetation, this coefficient can be linked to the height and to the leaf area index of the vegetation. It is also linked to global meteorological conditions such as air humidity and wind speed. For crops, tables are given by allele. On the graph here, you can see the crop coefficient function that we obtained for each type of land cover for the lead watershed. Next, please. Well, for conducting the sensitivity analysis, we applied the ABRESO tool, which calculates the effective precipitation for a theoretical watershed with a single land use, which can be either grassland, forest, or valley. In all cases, the same meteorological data were used, which are the analysis data that correspond to the center of the less catchment. And the results of the tool is the effective precipitation, which can be calculated by 3 different water budget methods. Next, please. Well, the results of this sensitivity analysis showed that the main differences in effective precipitation between grassland and evergreen trees are observed during the vegetation development stage. That means between April and June. Globally, effective precipitation for land covered by natural vegetation are in the same range, representing from 48 to 55% of the total precipitation. Vineyard crops induce less evapotranspiration than natural vegetation, especially in winter. Thus, it gives more water available for the hydrosystem. As for some area, no more than 10% variation of the effective precipitation is expected related to land use change. The next step of our work will be to evaluate the sensitivity of the hydrosystem model to this input. Indeed, we have to be sure that the approach is relevant to evaluate the impact of land use change on the water resources of the less aquatic. Thank you.
Thank you, Sandra. I'm going to continue with presenting the work of our graduate student Inès Martel, who unfortunately could not present today. That has been done in collaboration with Cécile Rivaud and myself. So the general question that we try to answer with this work is how people perceive these land use dynamics in the 2 sites that we are working in, and how these perceptions are influenced by their perception also of ecosystem services and disservices, what they consider as the state of reference, that is to say, a situation in the past that they consider was the point of start of the evolution of the territory, and also their vision of the territory in the future. So there has been a preliminary work that has been carried out based on a literature review, and especially some exploratory interviews with all the institutional bodies that are in charge of those questions in the 2 sites. And then we have been working on, especially Inès have been collecting data using a qualitative survey based on semi-structured interview, which is mainly based on a sociological approach. So it's a 1.5 hours interview that have been carried out with 12 people in each of the sites, with a diversity of people, farmers, elected people, firemen, foresters, NGOs, with the main group being farmers in our case. And so these interviews were fully coded, and then in these coded interviews, main themes that were mentioned by all the respondents were analyzed through the work. So just to give you a glimpse of the type of results that are just coming out of this work. For example, if in the LES, if you look at the perception of forest in terms of ecosystem services and ecosystem disservices, People mainly perceive that forests bring an advantage in terms of climate regulation, be it at the local level, also in terms of carbon sequestration, but also with a reduction of erosion. However, it creates some problems in terms of increased risk of fire, and especially we've had a very hot and with a lot of fires this summer. And also they consider that it creates a loss of water resource as compared to previously more developed pastures. On the Vistranck site, we have some results about the perception of abandoned agricultural land. And in this case, the ecosystem services that are perceived is that it protects wildlife and it has therefore a biodiversity advantage, but also that it increases soil quality. On the contrary, it's perceived that these abandoned land represent a loss of agricultural production, and also that it creates an increase of fire risk. Looking at the overall sample, the INES has been able to identify two main groups within our area. A first group, which is the pro-agriculture, which has been called the pro-agriculture group, that has a perception that these abandoned land have strongly increased in the recent past, and they mostly find these services associated with these abandoned land or the development of forests. And they basically want more agriculture everywhere in the future, and they are nostalgic about the past. On the other hand, we have a second group, which is that we call the pro-diversity group, that has a more mixed perception of the increase of abandoned land. Some see decrease, some see an increase. And they have also a more balanced view of the ecosystem and these ecosystem services, and these services that are associated to this land. And they have also a more balanced vision of the development of the territory, with a place for agriculture and also for natural areas. And they are basically more neutral about what was the past. So these results are going, as Cécile has mentioned, these results are going to be used in order to make a quantitative survey that will be implemented in 2023, in addition to the work that is being commonly done in social science with the other countries. So we are done, and we have a few minutes, 3 minutes for discussion, for questions if there are. I see the. Oh, yeah.
Yeah, if anyone has time for a quick question, we have a couple minutes before Italy begins.
Philippe, I'll ask, this is Tim. In the absence of any other questions, I'll just ask if you could comment briefly on your relationship with Oscar, and specifically what I'm wondering about is how things might develop regarding the effort you described of trying to determine what's been going on in terms of social sciences at the Oscar sites.
Okay, this is really I didn't mention it because nothing is really stabilized yet. So what we have done, so we have a collaboration with the executive committee of the Oscar. And I presented the project to them, and we agreed we want basically to try to organize a day of seminar in 2023, which is about the use of social science in the Oscar sites. Before doing that, we decided to conduct a short survey about what's been already implemented in the sites, and we have collected some answers that still need to be compiled. So yeah, we are still in discussion about what would be the format of such a seminar and who may participate. But this is happening also at the same time in which there is a global discussion about the fusion of different observation sites that are also dealing with social science. So we need still to find where is the place for that.
By the way, that was a very nice presentation by you and your team. I see there's a question from Saverio.
Yes, thanks. I will try to be brief. I was wondering, given that within the area there were different, slightly different change of land cover. In ones you had some recovery of agriculture, in the others not. if actually the people that replied to the questionnaire were somehow geographically connected to this place or not.
Yeah, the people we interviewed are really in the area where we are implementing our work. Really farmers that are working and experiencing land use in this area. So only this type of people were interviewed. So so we are able somehow to make a link between these perceptions and their effects on the critical zone. How we are going exactly to do that is still a bit unclear, but this is probably going to happen through the quantitative survey that we will implement afterwards.
Okay. Yes, thanks. I was wondering if the effect in some place where the vineyard were coming back, you were seeing some difference in the answer, but maybe you didn't. Will you look at these things after? I don't know.
Maybe Cécile can say a word about that if she understood what's the this question of the rebound of vineyards. I'm not sure if she.
Yeah, I think we should do this in the coming weeks, but we did not compare right now the two sites. We separated the analysis for the two sites, but we did not compare. The results are just coming now, so this is underway.
Yes, thanks.
Okay, good morning, everybody. Good morning, nice day. I'm Maddalena Pennisi. I will introduce shortly you to the presentation of the Italian team activity in ABRESO. Our main focus is to study, investigate land use change, and in particular abandonment of traditional agricultural practices in Italian Alpine mountain. And our team includes researchers from the National Research Council and from university, PhD students, fellowship, and of course, stakeholders. Grazie, next. Maria. Just a short, coming back to our case studies, we have selected 3 case studies that are located along the Alpine Arc. So 2 are in the national parks of Gran Paradiso and Val Grande. You will listen to Noaschetta and Val Grande. And another one is a silvopastoral system on the eastern side of the Alps in Trentino Alto Adige. So we have different stakeholders according to the national parks of the municipalities. The main focus we are following is the change from pasture to tree recolonization that affect all sites, but in particular from these first years of activity, we also see the vice versa phenomenon is occurring. So we would like to show you that our activity has a strong interplay between 3 pillars that are the so-called ground activities, that means soil biogeochemistry, geomorphology, plant physiology, and others. And changing to scale, we have the scale in space and in time. We have remote sensing activities focused on satellite orthophoto to produce maps for land coverage, snow coverage you will listening to. And finally, we just based on this natural science study, will offer first results to stakeholders that will be a question that we interpret and reanalyze by the social science group working on economic system, policy evaluation, and economic of territory planning, including some survey. So in the following, Andrea Scartazza, Maria Patrizia Damo, and Chiara Ricciardi will present results from the natural science, and Lisa Sella will follow with the social science focus. Thank you.
Hi, everyone. The next slide, please. The main objective of the ground-based researchers at Italian case studies was to evaluate the effect of the abandonment of traditional agricultural practices in the Italian Alps on the soil-plant interactions. At the soil level, we evaluated several physical, chemical, and biological properties, such as the particle size distribution, the aggregate stability, the pH electrical conductivity, the soil organic carbon and total soil nitrogen, the carbon-nitrogen isotope composition of the soil organic matter, and enzyme activities. At the plant level, we studied the plant biodiversity, carbon nitrogen concentration in plant organs, and some leaf functional traits, such as leaf mass per area, leaf pigments, and the carbon nitrogen isotope compositions. Then we evaluated how the soil-plant interaction changes affect the carbon fluxes and the provision of important ecosystem services, such as the carbon sequestration potential, the biodiversity conservation, the regulation of biogeochemical cycles, and water cycles, and so on. The next slide, please. Now I will show you some examples of these activities. In the pivotesinocytes, we study the transition from pasture to the old forest of Picha habeas along a transect including a monospecific advancing front of young Picha habeas trees. The pasture showed a high species richness with more than 20 species belonging to 10 different botanical families, and the transition from pasture to forest was associated with a drastic reduction of plant biodiversity. Next slide, please. These changes were affected also the soil physical, chemical, and biological properties. The particle size distribution of soil aggregates was determined through a laser granulometer before and after sonication in order to evaluate the differences in granulometric composition and in the mean diameter of the soil aggregates. The particle size distribution indicates that the granulometric composition was not significantly different along the transect, while, next slide, please, the median diameter, next, the median diameter of the particle size distribution that is assumed as an estimate of soil aggregate stability was lower in the forest soil, which showed also a faster decrease of this parameter during the first minutes of sonication, indicating a lower aggregate stability. This was also associated with other changes in soil chemical and biological properties. Indeed, pasture soil showed a higher pH and electrical conductivity and the different enzyme activities compared to Picha habeas forest soil. In particular, pasture showed a higher carbon-related and nitrogen-related enzyme activities with respect to the phosphorus-related enzyme activities, indicating that the transition pasture to forest induced strong changes in the nutrient cycling. Next slide, please. In all the case studies, we studied also the soil carbon nitrogen content and the relative stable isotopes. We observed large variations in these soil properties due to the different site location, the soil depth, and the land use. For example, in tesinocytes, we observed a decrease in the carbon nitrogen soil content during transition from pasture to the young forest of Picha habeas. And this was also associated with changes in the carbon nitrogen isotope composition, further indicating a strong effect on the carbon nitrogen cycling and on their interactions. The next slide, please. Concerning the leaf functional traits, we studied the relationship between the nitrogen concentration and the nitrogen isotope composition in the different plant species. On the left, you can see the mean values for the different sites. It is worth noting that the pasture sites show a generally higher leaf nitrogen concentration associated with higher nitrogen isotope composition with respect to the other forest and grassland sites. Moreover, in the non-scheta sites, we performed also a grazing exclusion experiment using the fenced plots. In these plots, we observed a decrease of leaf nitrogen concentration and isotope composition with respect to the control site. On the right, you can see a focus on the Tesino pastures, where it is possible to appreciate a large variability in the nitrogen concentration and isotope composition among the different plant species. This indicates that the pasture promotes a wide interspecific plasticity in nitrogen resource utilization and thence a diversification of ecological niches. In conclusion, the pastures show a high functional biodiversity associated with a high structural biodiversity. Next slide, please. This different nitrogen concentration was associated with the changes in the leaf pigments. The chlorophyll flavonoids, indeed, are good indicators of nitrogen status in plants, and under nitrogen deficiency, plants produce more flavonoids or carbon-based compounds. Our results showed that leaves of Pichia habeas showed a lower nitrogen concentration associated with the lower values of chlorophyll content and nitrogen flavonoid index, and the higher carbon-nitrogen ratio and leaf mass per area. Hence, these results suggest a different adapting ecological strategies and leaf economical spectrum between the forest conservative species showing a slow-growing strategies characterized by long-lived and nitrogen-poor leaves, and the pasture acquisitive species showing a fast-growing strategies characterized by short-lived and nitrogen-rich leaves. These different strategies affected also another important leaf functional traits. Next slide, please. That is the carbon isotope composition that represent a valuable proxy for time-integrated instantaneous water use efficiency, that is the ratio between CO2 uptake and transpiration water loss. Hence, an increase on leaf delta 13C indicates an increase of water use efficiency. We observed a linear, a positive relationship between leaf delta 13C and the nitrogen concentration expressed per unit leaf area, but different relationships were observed for herbs, deciduous trees, and evergreen indoor trees that suggest a different photosynthetic nitrogen use efficiency among the different functional groups. This was reflected in a change of delta 13C and thence water use efficiency among different functional groups and ecosystem types. And it's important to note that the transition from one type of vegetation to another one is associated with a strong effect on the carbon-water relation in our case studies. The next slide, please. Finally, we evaluated how this change could affect the carbon fluxes using two different methodologies: measurement of CO2 fluxes through portable accumulation chambers and dead covariance station measuring the net ecosystem CO2 exchange. We observed a large seasonal and interannual variability in the net ecosystem CO2 exchange. Now we want to investigate the effect of snow cover duration and length of the vegetative season, pasture pressure, land use change, and the climate change on carbon fluxes, productivity, carbon-water relation, and the carbon sink capacity. To reach this important goal, it is necessary to link the on-ground observation with those obtained from the remote sensing. And now, in the next part of the presentation, Patrizia Adamo will show you these results. Thank you for your attention.
This is the part of the focus on the research, remote sensing research activities at the Italian site. In the first year of the project, we have developed a method based on the data fusion of Sentinel-2 and MODIS imagery by means of random forest techniques to obtain a daily time series of snow cover. We aim to investigate how snow cover can affect the grazing season in terms of start and duration, the phenology and quality of grazing, and the water availability. From the daily time series of snow cover, we extract 4 parameters, main parameters related to snow. The first snow-free day, the last snow-free day, the vegetation, the vegetative season length, and the snow cover duration. This is the example of products extracted for Noaschetta, for Gran Paradiso National Park. And we validated this product with the weather station measurement. The same we have carried out in Tesino site, but the validation is still in progress. And we reported here try to understand how snow cover interact with the grazing season with vegetation. And on the left, you can see here the relationship between vegetation index, the MKR2, respect to the vegetation season length extracted by a snow cover product. In the case of Tesino, the 5 different locations characterized by pasture, by different grazing levels, different levels of management. And so we can see on the left that each location has distinct levels of vegetation index that are not impacted by the vegetation season length. But on the right, we see that the vegetation season length impact the average across season proportion of chlorophyll over the other pigments expressed by prop VI which is a ratio between the two different vegetation indices sensitive to different properties of vegetation. In order to understand the effect, to extend the time series from 2000 to today, we integrated also Landsat data in our time series and we have analyzed 20 years of trends of snow cover, in particular the snow line elevation, which show a shift toward higher altitude during these 20 years. Moreover, we have also obtained a decreasing trend of the extinction of glaciers and perennial snows during these 20 years, with an abrupt change occurred during the 2003, which is the year where a great European heat wave has been recorded. Considering the land cover changes activities, we want to address the question if stakeholders acknowledge the real changes in land cover. So we want to compare the observed land cover maps and the related temporal changes from 1990 with the web-based survey of a perception of stakeholder. To do this, we are extracting time series of land cover land use map from the 90s, so spanning 30 years of temporal range, and detect the changes. We are applying artificial intelligence-based approaches, deep learning, machine learning approaches by using a data set composed by Sentinel-2 and Landsat data, but also composed by Sentinel-1 data, so synthetic aperture radar data. We have two issues to address. The first one is the availability of training and ground truth available in the past. And the second one is the heterogeneity of landscape and the complex topography. This is a work in progress activity. So this is a comparison of two land cover obtained by intra-annual Sentinel-2 time series by applying support vector machine and using as ground truth an updated ground truth acquired during the project. Another problem we are trying to address is the transition from forest to pasture and vice versa. To understand if stakeholders acknowledge the real dynamics of forest and pasture transition. For this, we need the very high spatial resolution data, and we need to go far back in time. So we choose to use time series of orthophotos provided by stakeholders and an approach based on geographic object-based image analysis, which consists in 3 stages. In the first one, segmentation is carried out. The second one is the extraction of spectral, textural, and other spatial features. And the second one, the classification, is based on the knowledge and not on data. This is one of the preliminary results obtained by applying this procedure by using 3 orthophotos acquired in 1973, 2006, and 2020 for Malgatel Vagola, and comparing the maps obtained from in correspondence of 1973 and 2006, we can observe a transition from grassland to forest until early 2000s due to land abandonment, in particular, just only in this area, which is the area where the ground-based research has been conducted. Only in this area, 2.6 hectares of pasture. There is a loss of 2.6 hectares of pastures in favor of forest, which consists in the 31% of the area. Starting from the early 2000s, management activities and control has been conducted in the sites, resulting in a control of this loss of pasture here, but resulting also in a deforestation activities in this part of the site. Please, Chiara.
Yeah, good morning, everyone. My name is Chiara Chiardi, and this summer I had the opportunity, thanks to the Belmont Forum International Scholarship, to spend 3 months with Professor Xuling Guo Research Group, which conduct research on grassland encroachment by woody plants, gaining both fieldwork and data analysis experience on vegetation dynamics that will be applied in the Italian study sites of ABRESO project. Thank you.
Okay, so the very last part, I'm just going to show you how we are working in order to integrate natural and social sciences approaches in this case study. Clearly, we have one common aim, which is analyzing the land use changes in the Italian Alps, which are mainly interested by abandonment of traditional agricultural practices. We have one aim, but different objects, methods, spatial and temporal scales, meanings, wordings, values, and visions. Next slide, please. So we started with reflecting on the integration of data sources. You have already listened to preliminary results on field measurements and remote sensing satellites. And we are going to develop our social science work in order to integrate and complement natural science findings, in particular using quantitative data from the International Survey we have developed and we are developing with Janet's group, and she has presented in the very first day. And we will develop qualitative data in the form of semi-structured interviews to our stakeholders. They are depicted in the very last part, in the very bottom of the slide. And we are going to investigate with them their perception of land use change and their perception about the main drivers, the services and the services, and the management strategies and policies. Next slide, please. So I will conclude showing you the way we are integrating our research question. On the left column, you can observe the input we will have from the natural sciences, and on the right column, the social science part. And so we have, for the moment, we have developed 4 common research topics. The first one is land use change, and we will integrate land cover maps from remote sensing and related temporal changes and results from ground truth concerning plant biodiversity and biogeochemical cycles using an oversampling of the web-based survey on our sites, and then in-depth interviews to local stakeholders. Then we are addressing the snow cover item, trying to integrate the snow cover monitoring Patrizia has shown to you, and some ground truth results about the variation on water discharge by in-depth interviews to shepherds in order to understand if shepherds are aware of the effects that snow cover has on the grazing season in terms of start and duration, on the phenology and quality of grazing, and on water availability. Then we are studying grazing intensity. We have 3 forms of intensity in our sites: abandonment, grazing, and overgrazing. And remote sensing and ground truth will have some results concerning nutrient cycles and plant physiology and phenology and so on. And we are by interviews to shepherds, we are investigating if shepherds are aware of the effect on grazing, of grazing on biodiversity and nutrient cycles. And finally, concerning the transition forests to pasture and vice versa, we are going to integrate orthophoto satellite imagery and ground truth results by the analysis of territorial forest management plans and integrating them with interviews to local stakeholders. So this is the complexity of the work on the Italian sites, and we are done. We are in time. So if you have some questions, we are here. Thank you.
Yes, thank you, Lisa and the Italian team. That was great. We do have a few minutes if anyone has a question. The Taiwan team gets ready.
This is Tim. I'm asking a question of the natural scientists. I'm just curious to know if you think there might be any sources of water quality information for any of your watersheds.
Tim, this is the weak point at the moment, but we have done some sampling, punctual sampling, but we hope to have access to data also on discharge at the end of these valleys, in order also to compare with the snow cover, and also to have punctual analysis on the water quality also with respect to nitrate mainly. So we have the samples we will analyze, but this is still not done because we are waiting for a greater amount of sampling. So the answer is yes, but is subordinated. Should be have to be implemented now at the moment.
Thank you. And I'm just curious if you, because I remember having been to one of your sites. It's a water supply, and I'm just curious if the agency that's in charge of that might have water quality data.
Yes, let's say that the main point for water for us is Valgrande, where we still wait to put some instruments to record the data in continuous way. But we had some problems with authorization and others, so we are late with this point. And with respect to Noasqueta, we are doing this. Yes, we are working on this. So hope to show you some data next time, next meeting.
Thank you.
Good day, everyone. This is a progress report of the Taiwan group for the ABRESO project. This project aims to understand the abandonment and the rebounds in different countries. And I'm River Huang, work for Department of Geography, National Taiwan University. And another national committee is Professor Helin Jian. She is a social scientist, work for National Pingtung University of Science and Technology. Our group comprises some scientists and the students with different expertise. And today, most of the studies were presented by the postdoc and PhD students. So if you are interested in our group members, please visit the ABRESO website for details. And in ABRESO, we focus on the 4 research questions. The questions has been mentioned several times and guide our specific 6 studies in Taiwan. So we want to use those studies to find the proper way to achieve sustainability by merging nature and social sciences. And in this project, we select the reservoir catchment Pinling, located in northern Taiwan as our study area. And here is the spatial extent of Pinling catchment. In this catchment, you can see the land use change over the past 3 decades. The table shows the land use change since 1994 to 2015. And in this reservoir, the government has restricted the development for protecting water resources since 1987. Therefore, any construction and development are forbidden. And you can see that in this catchment, the forest is the main land use type. It covers over 90% of the entire catchment. And the agriculture and the building only accounts for 2.5 and 1.2% respectively. However, despite the small fraction, the arable and the building, in fact, decreased and increased considerably, considering their own basis. You can see that the agricultural land decreased to 2.6 and the building increased to 1.15. Is increased around 13% since the past 3 decades. And as for the climate, you can see that wet and warm is the main features in our study site. The average January and the July temperature are 13.7 and 26.4 degrees Celsius. And the annual rainfall is over 3,000 millimeters per hour with significant seasonality. And because of the warm climate, tea cultivation is the main economic activities here, can be harvested twice per year. And the 2 harvests named spring tea spans from February to April, and the winter tea from September to November. Certainly, some fertilizers and pesticides are necessary during cultivation. In general, you can find that the farmer usually applied 500 kilograms per hectare for each harvest during the spring and the winter, which means that it's around 1,000 kilogram fertilizer are applied in this catchment. And for the climate change, the left upper figures show the high temperature days over the past 3 decades. You can find that the high temperature days increased since 80 days to over 100 days per year since 2010, which means that the temperature is getting hotter and hotter. In terms of the precipitation, the rainfall during the early winter has increased significantly, but the rainfall during the early spring has decreased more or less, and the lowest rainfall during the early winter and the early spring corresponded to the tea cultivations, which means that the changes of the temperature and the rainfall inevitably affect the tea cultivation. For this year's example, you can see the right figures, and we just suffered a serious drought during August, and the tea withered very significant. The photo showed the tea trees withered in August, and the stream discharge are pretty low. However, after typhoon invasion during the September, the typhoon Himamo hit the northern Taiwan during the September, and you can find that the reservoir water level increased dramatically, and the magnified fluctuated climate is a challenging issue here, which may affect the perception of the local people or the tea farmers. As for the social science, you also can find the population structure has changed dramatically. The right upper figure showed the population pyramid changes with time. And you can find the baby boom with the time flies. The baby boom is getting older and older, which means that the labor population fraction decreased very significantly from the 68% dropped to 65. And the shortage of the labor indicates the shrink of the tea farms as well as the tea values, the tea yield. So under the specific geographic setting of our study area, there are 2 studies presented by the PhD student and postdoc that we want to show today. The first one is the transition of the human-water relationship in cultural landscape. presented by PhD student Fu Xinpei Fu, and that's what she said, what she found in this study.
Transition of human-water relationships in the cultural landscape of Pinling after 1945. And this is the outline for this presentation. The first question I would like to ask is, how has the human-water relationship in Pinling changed in these aspects? Their daily usage and customs, their agriculture and productive usage, and the recreational aspects. The second question is that how have government regulations and construction changed the human river relationship in Pinling? I reviewed several clusters of literatures, including cultural landscape and water culture, and also the previous literatures about Pinling. But sadly, in these literatures, I find little discourse about the water culture in Pinling. So to understand the transition human-water relationships, first I referred to the government official documents published by the Pinling District Office. For example, the two books, Pinling Xiangzhen, 岁月, and also in the past 1 year, I participated in a local group of youth. Their team is called the Collectors Co-Space, and here's their cute logo. They held a lot of activities for local community members and school kids, mainly to revitalize the traditional river-related crafts and to build elders' memories about this river. And also from the summer to autumn this year, I conducted many interviews with local residents. So about this study area, we all know it's an important water protection area in Taipei, the capital of Taiwan. So yeah, I will skip the further explanation about this place, and just to provide a simple information about its current industry, that till now we know in Pinling, their major industry is still primary industry. Over 75% is the farming, mostly tea farming. And in Pinling, they have tap water provided since 1970s, but till now the tap water rate is still very low, like 17%. And as for all my interviewees, I separated them into 3 age groups. Now this is the distribution of all these interviewees in Pinling, and we see that most of them live in the main street, the old street. And based on this interview, we learned that there are multiple water sources in Pinling now, besides the tap water, 17% tap water. Most of them relies on spring water in the middle of this page, and also a few rely on stream water and rainwater. Also, we noticed that the stream water has played an important role for their economic activities. But sadly, stream water has gradually lost its important role for providing economic production. And instead, the street tap water and spring water is the most important water source currently. And we saw that also difference among generations, that in elder groups, there are many riverside activities related to life basic needs, also economic activities. But in the midlife, they have more diversified recreational riverside activities. But for the younger generation, they no longer have any riverside activities related to basic needs and economic activities. Also, we see the declining traditional religious ritual in traditional funerals. Only the elders have experienced the traditional funeral that they went to the river to tap water and come back to clean the dead body. And then there's one open question in this interview, asking them what comes to your mind when thinking of this stream nearby. And we noticed that the elder group, what comes to their mind about this stream is mainly about their work or their job here. And then the midlife group, they have more diversified answer to this question related to their recreational memories and about their observation of this stream and the riverscape itself. And there's another open question asking them in the interviewees' life experience, have any changes happened in this river? And this is mainly for the residents near the big old street. Although it's an open question, we still collected multiple repeated answers, but mostly negative, like water getting muddier, and they notice there's less river fish, ponds, and crabs, and more river concrete engineering and less riparian vegetation, and disappeared riverside large rocks. Okay, so besides the generation difference, we also find aerial difference, like residents away from the mainstream or at higher altitude, they have less connectedness to water. Instead, have more connectedness to hunter culture. And also gender difference, that comparing to male elders, the female elders have little memories of river recreational activities. And our first discussion is the transition of human-water relationship in the following aspect. So here I made a history timetable comparing with the government management and construction transition. And based on these, we enter the next discussion to analyze how government regulations and construction has changed, has influenced the human-river relationship in Pinling. And we find that although policies and regulations did raise residents' awareness to protect the river, but on the other hand, there are more negative effects brought by the constructions. For example, the local traditional skills inheritance decline, the individual responsibility in water supply decline, the responsibility in the government arise. And also we hear residents complaining about how the riverside engineering, the constructions, make their accessibility to the riverside declined. Currently, I still need to collect more respondents, especially the young adults group and midlife females. And then after this next stage, I will try to understand how the river cultural revitalization group, how their river education program help to enhance residents' place attachment and lead to more pro-environmental behavior. So thank you for your listening. Hello everyone, I'm Xinpei Fu.
Okay, and in her study, you can find that the local paper perception in terms of the policy, construction, and the social transition, in fact, it has been changed with time. And for example, the perception of the elder mainly focus on the basic needs and the economical activities. However, the young group mainly focus on the recreations, which will be changed or affect their attitude on any policy changes. And Sarah, please can help me to play the second video for the nitrogen and carbon coupling.
Hello everyone, I'm Hao Zhilin in National Taiwan University. Today I'm glad to share my research. My study focuses on the impact of the agricultural land use on the dissolving nutrients relating to the carbon and the nitrogen cycling in Taiwan mountains rivers. So what kind of the dissolving nutrient in the freshwater ecosystem? There are DOC, DON, and the DIN. The DOC is the dissolving organic carbon. DIN is the dissolving inorganic nitrogen, including the nitrate and the ammonia. The DON is the dissolving organic nitrogen. That is the interval of the nitrogen and the dissolving inorganic nitrogen. First, let's say that the DOC on global scale. The average of the DOC was around the 5.6 milligram carbon per liter. the DOC flux was around the 1.4 ton square kilometer per year. In Taiwan, that is quite low, around 0.8 milligram carbon per liter. However, due to the high discharge, the DOC flux was higher than the global scale. On the other hand, the dissolving inorganic nitrogen flux, DIN, was around the 3.8 ton nitrogen per square kilometer per year. That is higher than 18 times than the global average. Therefore, our question is why we found the extremely higher DIN under the low DOC water body is due to the agricultural impacts such as the over-fertilization or the other reasons. That is our study site, Phase 3 Reservoir Watershed, FRW, providing water supply for the 6 million people in the north of Taiwan. We investigated the 19 sites to collect the water sample of the dissolved carbon and the nitrogen. In addition, we categorized the low agricultural land use, defining to the area of the farm was less than the 1%. The higher one was more than the 10%. Our results was shown that the low DOC was controlled by the stream flow of discharge. The blue line is the discharge, which measures control the DOC concentrations. On the other hand, the DON and the nitrogen loading under the highly agricultural land use were 10 times higher than the low one. Considering the discharge in estimated dissolving nutrient flux, also we found the same pattern of the water sampling. The DOC flux was not clearly different between the high disturbance and the low disturbance, but the DON and the nitrogen loading were higher than around 2 to 6 times under the higher and the low disturbed bed. According to the previous studies, the CN cycling were not independent process. The relationships of the DOC and the nitrate have the pattern like a normal distribution. Due to the remarkable stoichiometry requirements under the carbon limited, the nitrogen cycling process preferred to do the nitrification, producing the dissolved oxygen until to the threshold of the carbon limited. The microorganism prefer to uptake the nitrate, consuming the dissolved oxygen, and the DOC was accumulated. In our investigation, we also can find the pattern. The threshold of the DOC was around the 100 micromole carbon per liter. Interestingly, they have the different threshold under the lake ecosystem. In the Taylor and the Towson paper was around the 515 micromole per liter because the different discharge residence time and the biomass and also the land use, we can test this hypothesis in the future. So we found the nutrient export and the stream flow measuring impact the time series of the DOC, UN, and the nitrate concentrations and the fluxes in fresh water ecosystem, the Phase 3 Reservoir Watershed. We also found the DOC versus nitrate concentrations as a normal distribution. The threshold of the DOC was around the 100 micromole carbon per liter in Phase 3 Reservoir Watershed. Thank you very much.
Okay, this study is mainly want to test the hypothesis of enriched nitrogen hypothesis, which say that the DON, dissolved organic nitrogen, will increase with the DIN with the nitrate, and we found that it may not perfect correct in factory reservoir, and also how this study is highly associated with the secure relationship which has been introduced in the last Monday. So Sarah, will you please play the third video presentation? Thank you.
Hello everyone, I'm John. I'm from Taiwan. I'm a 4-year PhD student studying at Pingtung University of Science and Technology. Today I would like to talk about the Belmont project in Taiwan. I work on this project with my professor, Dr. Holin Jian. This presentation is into 5 parts as shown here. A socio-ecological system consists of biogeophysical units and its associated social actors and institutions. Socio-ecological systems are complex and involve interaction to influence system dynamic. This part of the challenge has led to a growing focus on how society organizes governance and institutions. In the government process, the role of the government is particularly important because the government is the maker of the system. We need to develop a better system of regulation to help local sustainable development or to adapt to different environmental conditions. It is also found from the literature and that effective governance can promote the different management and use of public resource. So we decided to take Taipei water source conservation area. This specific catchment area covers an area of 717 square kilometers and is governed by 2 different agencies in Taiwan. Because of its importance is domestic water supply and tea conservation, the economic source of this area is dependent on the conservation and sale of tea. And at the same time, this area needs to protect the water source that supplies tap water to about 6.5 million people in the Great Taipei area. In the city, people hope the water quality will not be damaged or polluted. And our focus in the Pinyin area because it is the most active area. Next, my main research performance in Taiwan is the social science, and this year my professor and I co-authored an article. And the main research question was about the gap between governing institutions and local stakeholders' performances, the watershed socio-ecological system. In addition, I also went to Japan to conduct research through the project files. I'm working here with my supervisor Kuma-san and Saito-san. In Japan, I study how to hydrological simulation with WEAP and discuss how to use pyramids for ecosystem service approaches, address water inequality, and improve human well-being. So now I will talk about my research methodology in Taiwan. We decided to use the social fit that aims to understand the gap between governing institutions and local stakeholder performance in the watershed socio-ecological system. So we conducted in-depth interview with 7 villages, 35 people, and aged between 25 to 70, which are all tea farmers, village chiefs, and young farmers. We find that they are very concerned about the water shortage, whether the people live whole or agriculture, restricted construction, and other issues. And they really hope that the government can provide improvement measures. And another map is the couple infrastructure system approach. First, we collected 5 years of data in the government's procurement network and then divided its governance facility into 4 parts. One is the part human-made infrastructure, which refer to traditional infrastructure like road construction or hillside land improvement. 2 is the surface human-made infrastructure, which refers to government subsidies for local agriculture or landscape maintenance. And 3 is natural infrastructure like rivers or wetlands. And final is the human infrastructure and social infrastructure. That together refer to land use, education and publicity, visiting activities, art and cultural activities. So we have looked at the map and we can talk about the result. So we analyze social feeds and find that the government actually invest a lot of infrastructure, either hardware or software. So you can see the table on the left. This is the government's invest. And you can see the table on the right. There is the stakeholder perception. So the first one, their concern is about the lack of water, but it still fails to meet its potential and needs of local stakeholders. And as you can see, you can see the government invests in 5 projects like this picture: hillside maintenance, road works, landscape, public construction, and the tap water construction. And the tap water construction is the last of the project. Then another concern that we find is the restricted construction. So the government cannot respond to the people demand for building restriction because the law is too strict. And the stakeholder hope that in the future the government can actively discuss with local residents to improve area and encourage local sustainable development. And the third concern of the stakeholder is about agricultural subsidies. But why can the government meet the needs of people? Because the threshold applied for applying for subsidies is very high. It's not friendly to young farmers or farmers who rely on leased land for cultivation, and the publication qualification are difficult. So considering everything we have said, here is a list of suggestions. And 1, we need a better social fit between governments and local stakeholders in the area of Pinyin. 2, we need to increase the permeability of water infrastructure to address water scarcity. 3, provide subsidy for restricted construction work. 4, improve the integrity and convenience of agricultural subsidies. So in the future research, I will focus pyramids for ecosystem. Finally, I really appreciate for the Belmont project, which allow me to go to Japan for this my future research. And this completes my presentation. Thank you for listening.
Okay, Chelong's study showed the environmental injustice in Pinyin, which is another issue for the social science. And 3 presentations are the progress report of Taiwan group. And that's all for today.
Thank you, Robert.